Probability random variable grade 12 GSLSES. During April, the manager of a sport offers to its members 3 types of activities: volleyball, basketball, tennis. Each member joins only one of these 3 activities. We noticed that 30% of the members join the volleyball, 20% join the basketball, so the others, that is 50%, join the tennis. Also that out of 5 members who join the volleyball, 1 of them attend the gathering day. 25% of the members who join the basketball activity attend this gathering day, and 70% of the members who join the tennis activity attends this gathering day. Consider the following events. V, the member joins volleyball. B, joins basketball. T, joins tennis. And R, the member attends the gathering day. Arrange the data by a tree diagram. We have 3 activities, 3 disjoint sets. These sets are volleyball, basketball, and tennis. 30% join the volleyball, so probability of V equals 0.3. Similarly, probability of B 0.2, and the probability of tennis equals 0.5. Now, out of the members who join the volleyball, we have 1/5 of them attend the gathering day, so 4/5 do not attain the gathering day. Similarly, for the basketball, we have 25% attain the gathering day, so 75% do not attain the gathering day, and similarly for the tennis. Now, to enter the gathering day, the member must pay 15,000. Also, to join the activity of the tennis, he must pay 100,000. The volleyball, he must pay 60,000, and the basketball, he must pay 50,000. We want to define a new concept in a probability, which is a random variable. Here, I take the random variable. It is equal to the total sum paid by a member in this club. What is a random variable? A random variable is a function that gives for each outcome in this sample space a real number or a number. For example, here we have 6 types of members. Volleyball and gathering day. Volleyball without gathering day. Basketball and gathering day. Basketball without gathering day. Tennis and gathering day. And tennis without gathering day. So, if the member joins the volleyball activity and attends the gathering day, he must pay 60,000 for the volleyball and 15 for the gathering day, so he must pay 75,000. So the first value of X is 75,000. The member may join the volleyball and he may not attend the gathering day, so he only pays 60,000 for the volleyball. So the second value of X is 60,000. If he join the basketball and the gathering day, he pay 50 plus 15 equals 65,000. If he joins the basketball only without the gathering day, he pay 50,000. If he joins the tennis and the gathering day, he must pay 115,000. Finally, tennis only, he must pay 100,000 only. Then we have 6 possible values of X. These possible values of X are 75,000, 60,000, 65,000, 50,000, and 115,000, and finally 100,000. So each member of this outcome, we assigned for it a number. This number is the aim of the random variable. The random variable gives every member of the outcome a number. Now we want to determine the probability distribution of X. It is to find the probability of each value of X. Here we have 6 values of X. First, probability of X equals to 75,000. Here, 75,000 corresponds for the event R intersect V. Apply the rule, it is R slash V times the probability lil V, so it is 3/50. 60,000 correspond for the event volleyball without gathering day, which is R bar intersect V, V which is equal R bar slash V times probability of V, which is 6/25. Third, 65,000, this random variable correspond for the event R intersect B. So R intersect B, probability of R intersect B equals probability of R slash B times B, which is 1/20. And similarly for the other events, this process is called the probability distribution. That is, for each value of X, we find its probability. Note that summation of these 6 probabilities is equal to 1. Calculate the expected value, or it is called the mean of X, and it is represented by EX. I will put the data in a table. What do you mean by EX? It is the sum of each value of X multiplied by its probability. So it is equal 50,000 times 3/20 plus 60,000 times 6/25, etc., etc. So we get 84,900. What does this number represent? It is the expected money to be paid by a member in this club. Maybe this member, maybe he pays 115,000, maybe 50,000, but the expected value is 84,900, or the mean or the average money paid by a member in this club is 84,900. So if we are asked this question, part D, suppose that 200 members joined the club during April. Estimate the revenue. What do you mean by the revenue? The revenue العائدات. يعني it is the money received by the manager of this club. If you want to estimate the revenue, the average money paid by one customer is 84,900. So by 200 members, the revenue equals 200 times 84,900. Now, the expected value, or the probability distribution can be represented by a bar diagram. Simply, we write on the x-axis the values of X, and on the y-axis, we write the probability. For example, 50,000, the probability is 3/20, which is 0.15, and so on. This is called the bar diagram of distribution. Determine the variance of x vx. The variance equal the ex square minus ex all square. Ex all square is the expected value that was calculated before to the power 2. But what do we mean by ex square? Here we find the square of each value. Look here, we find the square of each value. And then for this new set, we find the expected value. This expected value is called ex square. So we multiply 50,000 square times 3 over 20 plus 60,000 square times 6 over 25, etc., etc. The answer obtained is called ex square. Then the variance equals ex all square minus ex squared, sorry, the variance equal ex square, which is 7,916,500,000 minus ex all square, which is 84,900, and we obtain the result. What do we mean by the standard deviation? It is the radical of the variance, which is approximately 26617. Now we want to define the distribution function. The distribution function, denoted by capital F, it is a function whose domain is R, but its range is 0.1. That is, the answer of this function must vary between 0 and 1. What is this function? The function f of x, note that you must differentiate between small x, which is the variable of the function, as we know, and the big X, which is the random variable, okay? Now, f of x equal probability that the random variable is less than or equal to x. For example, if I want to find f of 20,000, this means I want to find the probability that the random variable is less than 20,000. But look in the table, the random variable x cannot be less than 50,000. So this event is impossible. So its probability is 0. Similarly, if I want to find the distribution function of 49,999, it is the probability that x is less than 49999, which is impossible, so it is 0. So the distribution function is equal to 0 if the variable is less than 50,000. Third example, f of 50,000, it is the probability that x less than or equal to 50,000. Here, it is possible for the random variable to be less than or equal to 50,000, which is probability of x equals to 50,000, which is equal 3 over 20. So, if I want to find f of 59,999, it is the probability that the random variable is less than 59,999, which is also possible. It is the probability that x equals 50,000, that is 3 over 20. So I can deduce that f of x equals to 3 over 20 for any value between 50,000 included and 60,000. Another example, f of 64,999, that is the probability that the random variable is less than 64,999, which is the random variable equals 50,000 or 60,000, which is equal to 39 over 100. So we can deduce that the distribution function is equal to 39 over 100 for any value between 60,000 included and 65. Similarly, for the other cases, you can solve them alone. Finally, here I want to calculate f of 115,002. It is the probability that the random variable is less than 115,002. So it is the probability of x equal 50,000 plus 60,000 plus 65,000 plus 75,000 plus 100,000 plus 115,000, which is equals to 1. Finally, the distribution function may take these values 0 or 3 over 20 or 39 over 100 or 15 over 25 or half or 13 over 20 or 1. That is, before this value it is equal to 0. Between this value and this value it is equal to 3 over 20. Between this value and this value it is equal to the sum of this probability and this probability, and so on. And we can draw the graph of the distribution function. Note that, for example, here f of x equal 3 over 20 if x is between 50,000 and 60,000. Note that here 50,000 is included while 60,000 is excluded. Thanks for your listening.